Alright, so this is chapter 11 notes, and our first part is sequences as functions. And the numbers we're doing are 22, 25, 38, 43, 46, and 47. Let's open up. This first section will be fairly easy. There's a lot of definition stuff in the beginning. But basically what we're doing is there's two types of sequences. There's arithmetic and then there's geometric. Let's show the examples off the bat. But I gave you two examples that are not arithmetic sequences first. So the way you can find out if it's arithmetic sequence is you need a common difference. So it's either added by the same number each time or subtracted by the same number each time. So when we go through here, we are subtracting 11. And then here we're subtracting 21 from going from -6 to -27. Well, that doesn't work. And then here it's -1. So this first example is not arithmetic sequence because there's not a common difference. The second one, we're going up by 12, and then up by 2, and then up by 4. Again, that's not a common difference. So we need something in the sequence that's a common difference. I'll give you a third example here. Let's go with 1, 5, 9, and 13. Now I just picked these numbers randomly, seeing maybe this is an arithmetic sequence. So this first one, I'm going up by 4, second one up by 4, and this third time up by 4. So I'm adding 4 each time, and this is the common difference. So yes, and then our common difference is a positive 4. Alright, so that's arithmetic sequence. It's just, is it going up by a certain number, adding or subtracting? And then we have geometric sequences. These are where you need a common ratio, something that's being multiplied or dividing. Now I'm really going to talk about the multiply because you can multiply by a third or divide by 3. That's the same thing. And up here we're just going to write adding or subtracting for arithmetic. Alright, so now this first example we have 2 to 6. Why am I getting from -2 to 6? Well, for just 2 to 6 it's going to be 3, so I multiply by 3. But I went from a negative to a positive, so it must be -3. So -2 times -3 is 6. 6 times what gets me -18? Well, -3 again. And from 18 to 54 is multiplying by -3. So these are all just multiply by -3, multiply by -3, multiply by -3. Another way that you could look at this is just make it a little bit bigger. So we go from -2 to 6 to -18 to 54. So how would I go from -2 to 6? Right. I multiply by -3, multiplied by -3, multiplied by -3. So this common ratio is multiplying by -3. Yes, so I put a little X there. So this first one is a geometric sequence. And then B, let's see if this one is. From 8 to 16, I went by and I times it by 2. But then 16 to 24, 16 times 2 is 32. So this was, I think, times it by 1.5. Right there I can say, no, not a geosequence. It needs to be a common ratio, which we'll later talk about. That's just called R. And if for the case of just arithmetic sequences, you need a common difference, which we will call basically as D in the next couple sections. So your homework now is on the back page. A couple of things I really want you to pay attention to is this section right here, being able to label the next 4 terms. So you need to find the common difference. So just for example, number 26, we go 10 to -6, -14. you will find out that your common difference is -8. So now to find the next 4, you're just going -14 minus 8. Okay, so minus 8. So we have -22 minus 8. And you continue that way. And then this would be the first one in the next 4. So there's that I want you to pay attention to, as well as the same thing for the geometric sequences. And then you need to be able to determine, is it arithmetic, geometric, or neither? So it's either got to be added by the same number each time, or multiplied, or subtracted, right? Addition, subtracting is this one. This would be multiply or divide. So that's just 11.1. Fairly simple, fairly just rudimentary.